Hello everyone, so today I'm back with a brand new atmosphere for you guys. I picked this spring piano for today's lesson so you can feeling upbeat during my session. Okay, so for this problem, we're still in the flow measurement. The problem is about the weir of a 8 meters long L, which is going to build across a rectangular channel to discharge a flow of 9 cubic meter per second. So if the maximum depth of the water on the upstream side of the weir is to be 2 meters, what should be the height of the weir? So they're actually asking for the height of the weir. So let's go back and take a look at the diagram of the weir. How does it look like? How does the weir look like? So this is like the kind of the weir. So they're finding the height of it. So it says that the discharge that is going to flow like this is going to be 9 cubic meters per second, and the maximum depth of the water is 2 meters. Uh, Wait a second. They also gave you the CD that I forgot to include in the problem here. Yeah, the given CD equals to 0.62. Okay, so now let's start solving the problem together. So the music today is really good. It's giving a good mood for a study. So given L, which is the length, equals to 8 meters, flow rate Q equals to 9 cubic meter per second. Depth of water is 2 meter, and CD equals to 0.62. The songs are so good. Okay, so now let's find the height of the water. So the height here, it refers to the height of the water above the sill of the weir. So let me just check a second. I want to make sure the sill of the weir is the right place that I'm trying to show you. Okay, so when there's water coming like this, there's a part here, a little bit part here. It's called the sill of the weir. So that's what they're asking. Okay, so now let's find the discharge over the weir. So this is the height. Fine. Okay, solution Q equals to 2 over D C D L square root of 2G, there's only 2G here, and times this the H 3 over 2. Okay, I think we're set to go. We know that this is 9 QMS. QMS, it's CMS. I'm getting a little bit playful today because of the music theme here. So it's 9 cubic meter per second equals to 2 over 3. CD is 0.62 times with L, which is probably, why am I saying probably? Which is literally 8. I shouldn't get a little more playful, just the right amount of playful is enough. Times with 8 meters, times with, everyone knows this, 19 point, yeah, I forgot, 62? Yep. Times with, H, we're finding the H here, 3 over 2. Okay, so basically, um, we're trying to solve for the age, so we can use our solver here to solve the value for you guys together. So basically, um, where should I start here? It's 9 equal to 2 over 3 times 0.62 times with 8 times with square root of 19.62. The answer is 14.646. 7, so it's supposed to be 7 here. I just realized that we don't need to use a solver because we can just rearrange the equation so that we can get that one beautiful equation here. So h to the power 3 over 2 equals to 9 over 14.647. So 9.647. Okay, so I'll do this first and we can rearrange it later. The answer is 0.61446 is 5. Actually, you're supposed to only have 3 digits. Yeah. H 3 over 2, H equal to 0.615 to the power of 3 over 2 over 3. So 0.615 to the power of 2 over 3, 3. So the answer for H is 0.672 meter. So now we need to find the height of the weir. So we know that the height of the water, the depth of the water is, this is more like the height of water above oil sill, and this is the actual height of the weir. So the height of the weir is 2 meter minus with 0.72 equals to 1.28 meter. So this is the answer. Oh, we're quite going a bit fast, right? Okay, so now we can continue to the next question. Let's say is that did we go through this one already? Okay, so a narrow crested weir of a 10 meters long. Oh wait, for a second, sorry. I just want to put this up there so I can send to you guys in a very neat, nice paragraph. So this is given from the problem. Okay, so now we can move on to the next one. Oh no, not. Oh yeah, this one. So that's it. Okay. Really? We finished the session? Yeah. Good job. Okay, a narrow crested weir of a 10 meters long is discharged under a constant of a 400 millimeters. So find the discharge over the weir in liters per second and assume the coefficient as 0.623. So now this is what we're going to look at on. Let's write the given value first. L, length of the, we would say it's the length of the weir, right? So L equals to 10 meters and H, head rate equals to 400 millimeters equals to 0.4 meter, because it's supposed to be 400 times 10 to the power of minus 3, so basically 0.4 meters. And constant CD equals to 0.623. Yes, that's it. So we know that the discharge, that's the same equation that we're going to use. Q equals to 2 over 3 CD L square root of 2G times with H 3 over 2, and then we can find the Q later. So in this case, we're not going to solve for any particular variable because they're asking for the discharge. So all we have to do is to find the Q. Excuse me. Okay, so I'm back. So in this case, we're trying to find the Q, which is the discharge rate. It's going to be 2 over 3, the same here. And, oh my god, this is not nice. 3 here times with 0.623 times with the length here, which is 10 meters, times with square root of 19.62 times with H, which is 0.4, 3 over 2. Oh, it's very easy for you guys. Very easy. 2 over 3 times with 0.623 times with 10 times with square root of 19.62 and times with 0.4 to the power of power. I normally agree with my calculator, so okay, so the answer is 4.6554. I don't know if you guys realize that this is kind of OST, instrumental music, but it won't distract you guys, right? If you don't really watch the K-drama that much, but I kind of realized that it's from some songs, so it contains lyrics. Okay, so the answer is they're asking for the liters per second. So 1 meter cube has 1,000 liters. 1 liter equals to 1 decimeter cube. So answer Q equals to 4.654 times with, should I do something like meter cube per second times with 1,000. Ding 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 ding. Oh, I'm being a little playful again. And it times with 1 to cube 1. What am I doing right now? Oh, 1 liter. 1 liter per 1 decimeter cube. So normally we put the thing that we want to find on the up here, and the thing that we have to convert like equal something here. So we want to find something, we want this one, we want this one, so then we can cancel this one out and we can cancel this one out. Final answer is 4.654 liters per second. Well, this is so easy. I hope in the exam it's going to be something like this so we can solve it faster. But this is not the end, guys. This is not the end for you guys, because I have some additional what do we call that, additional problems for you guys to solve it together. I would like to apologize for not having the preparation and typing all the papers on time. So let's just write it down. So it might consume some time, so you can just skip forward around like 5 minutes or something until I finish writing the problem for you guys. So I also want to show you just the solution, but I'm afraid that you don't really like know what kind of things I'm trying to say, right? So now it's like a discharge over a trapezoidal weir. So for the discharge over a trapezoidal wheel, where there's a water, not a water, there is some water flowing over a trapezoidal with a 4 meters long under a head of 1 meter. So now the question is, compute the discharge. Find the discharge or find the flow rate of the water if the I'm sorry if the coefficient of discharge is 0.6. Yep, this is the answer for this one. So now let's find the L. The given, this is a solution, okay. Solution, L equals to 4 meters. As you can see here, it's 4 meters. And then we have the H, which is 1 meter. And then we have the CD, which is 0.62. Am I right? Oh, 0.6, yeah. So in some parts, they're going to be 0.623, 0.62, or 0, even like 0.6. 6, just normal 6 like this one. It depends on the equation. So we have to use that same equation again. Just trying to make sure that you have the same, you are familiar with the same equation again and again. 2 over 3 CDL square root of 2G times with H 3 over 2, and the final answer is not it there, just substitute it first, times with 0.6 times with L, which is 4, I guess, yeah, 4 times with 19.62 times with H H, we know H, right, is 1, 3 over 2. So the Q here is going to be 2 over 3 times 0.6 times with 4 times with square root of 2G times 1. Why would I times 1? It is still 1 over it. And anyway, so the answer is 7.087 meter cube per second. This is not the they didn't ask for us to convert anything, so just keep it as in cubic meter per second. So that's another what do we call this one? Another thing and that the problem ended. So, uh, um, yeah, we ended quite fast for today. Uh, oh, I guess there is some exercise that we haven't finished, right? I'm just going through again because we still have some time here. Um, do we? Okay, so that's all right, and we also have those from um open channel was already finished. Oh, we're going quite fast. And triple one. Oh yeah, we have this one and this one next. Mm-hmm. Hello guys, I'm sorry. There's some technical errors. I need to charge my pen for a little bit, so now I'm back with the exercise from the laminar and turbulent flow. For this one, it says that there are three tanks A, B, C, which the water surface level from 100 to 500 and 10 meters are connected by pipes AJ, BJ, and CJ to a common joint J. So with a level of 45 meters, so the three pipes are having the same length and a diameter and the friction coefficient. So I would like to draw a picture, a diagram, so that you guys can understand. It's a little bit hard. It's not a little bit hard, it's very, very hard. Okay, so I need a 10. Wait, this is, I wanna, I actually don't want a perfect diagram, just a rough diagram that you can understand the concept of the problem, but as I'm drawing, so I want it to be a little bit perfect, so, sorry guys for wasting so much of your times. You can fast forward this one or increase the playback to somewhere around 2 times or something. If you know me, you know me. That's what people say. If you know me, you know me. So this would be the elevation, not the elevation, surface level. So the surface level is 100 meters. So if this is 100 meters, should I write it like this? Okay. So I'll just copy and paste. This time I'm a little bit smart. Copy, and it is lower than this one for like 5. So 1, 2, 3, 4, 5. Perfect. No. I mean, I want this one. It's the time that I am becoming lazy and just copy and paste. This is 50 meter. So then, oh wait, why don't I just copy everything here? Why should 10 be? 10 supposed to be, okay, so this is 40, 30, 20, 10 is here. Am I right? To be precise, 10 is actually here, right? Am I right? 10. Huh? Or am I wrong? Yeah, I'm wrong because it's supposed to be, this is supposed to be 1, right? 2, 7, 6, 5 is here. Right? 1, 2, 3, 4, 5. Lower. It doesn't have to be this realistic, but it's better for your vision if you're trying to like read the values together. Just an estimation. 1, 2, 3, 4. So 2 steps lower. You can just draw it like this. I mean, draw like this, and the water here, so it represents 10 meters. But I already made a mistake, so whatever. Okay, so this would be like this, and the pipe. It's connecting like this. make sure that the pipe is connected. Okay, so the pipe is connected this way. I'm going to push this one further a little bit. Isn't it supposed to be a little bit like more further here? I think I'm wasting my time here. Right? I am, I really am. I'm so frustrated right now that I cannot draw a perfect picture here. I'm not trying to find a perfect picture here. Oh, so you're trying to find another problem with me? Okay, whatever. 45 is here. Yeah, because this is 10 and 5 is around here. Okay, so basically you will see that it's somehow really, what do we call that, really nhai, but you can see that the length, the actual length of here and the actual length of here and here, it is somehow not placed on a line, that straight line like this. 10 is here, this here is here. No, it's actually on, we can say it's a mountain or something that is not the flat surface. That's going to see it in some different parts here, but the length here, the length of each pipes are the same, and this is the point J. So point J is here, this is point B, this is point C, and this is point A. Okay, so you go back here. Yep. So now let's compute it together without wasting our time anymore. Oh, they're asking for the head of joint A. Okay, so find the head of joint A. So Q equals to, the Q of this part AJ here equals to the Q of JB plus with Q of JC. I would say that it's because of AJ is higher than JB and JC. Is that the point? Yes. Okay, so now we can continue to the next equation. We can also write H, which is the head of A, equals to head of J, plus with the friction loss of AJ, pipe AJ. So we would say that we apply the Bernoulli's equation here. So we have 100 equals to HJ plus friction AJ. So the answer here is we rearrange the formula, the equation to the left side. That's 0. And actually you can just do it like this. Equals to HF AJ and then 100 minus H head of J equals to F AJ equals to KQ. This coefficient, I wonder if you guys have remember from the pipe work that we have this think kq squared before we find the head, right? So we know that k equals to 32 FL over pi square G d5. So what we're trying to find this term. Is Q AJ equals to this. I would say this is square root of everything because we're trying to fix everything inside the thing here to find Q, right? So 100 minus H head of J, head was head of J, and HF is the head loss of friction in the pipe. And we have K. So the answer that we have here is this is the final equation 1. Why am I trying to ask for an answer if we're only finding the equation? Music, just so you know, I need a lot of music to help me wake up. So I hope it applies to you guys as well. For the similar, the Bernoulli equation can also apply between apply between J and B as well. So for J and B, it's going to be the same equation as Hj equals to Hb plus Hfjb, and then we can continue and repeat it. Yeah, we keep repeating all of these until we have both three equations. Okay. Okay, I keep turning off my mic on and off. I hope you don't mind this. Okay, so now let's work on the continuing problem here. It's going to be Hj equals to Hb. You can also do it while I'm solving this one, in case that you can solve faster than me. Then we have Hj minus Hb equals to HFJB. Okay, so this is 500 550 equals to HFJB equals to KQ squared of JB. And then we have the same thing here. Q of JB equals to the square root of everything here. It's going to be Hj minus 500 over, again 500 again, it's only 50. Then this is the equation 2. Let's highlight it so that we can remember. We also need to highlight the first equation as well. It's here. And we can move into our last equation here. So for our last equation, it's going to be Hc. So point C equals to, so the equation for point C is Hj equals to Hc plus Hf Jc. Jesse. Oh, I think that should be a shortcut for people who name Jesse, like JC. or it already exists. I just found that. Hc equals to Hf Jesse. And this is it remains unknown, and Hc is 10 equals to HF JC equal to KQ square root of Jessie. So now we're trying to find Q of Jessie. It's going to... Why am I keep saying it's Jessie? Jessie A, show debut. Who are the fan of Jessie A show debut? No one. So this is the equation number 3. I'm going to put it in another highlight so that we can have 3 colors on the same page. For the next step that we're going to use, we're going to construct a table, but I think that's going to be a really hard thing for you guys to do. We are trying to find HJ, right? Which find the head of joint. Joint J. Oh, when did I get this wrong? Why no one is telling me? Okay, so it's joint J, and yeah, we're finding HJ. You actually need to construct a table in the Excel. I know that there might be some equation that we're going to find. Let me see the K here. I think the K here, if they say that the friction is the same, L is also the same, diameter is also the same. So K A equals to KB equals to KC. Now let's put all the 3 equations together. Is it nice? Yeah, useless. Of course, a flow rate are not the same. As I already showed earlier, the flow rate is only the flow rate. Only the flow rate of this one is equal to this one. Where is it? Yeah. So if this one is equal to this one, it's going to be 2QJB. So this QAJ equals to 2QJB. And there. 2 equals to this. Huh? So everything here, square root of. I got it. And then we have another round here. 1, 2. Sorry for being a bit playful today. I've been so stressful lately. That's how I release my stress, by doing all the silly things, maybe or not. So let's see. Yeah, it's going to be this way. 1 is 100. Wait a second. Is 2 and 3 equal to each other or not? This is my answer. And this is my question. No, it's not, right? G. Yeah, it's not. Why did I think it's the same? K plus square root of HJ minus 10 over k. I'm trying to find a way that we're not going to use Excel, because we cannot use Excel in the exam room. But I also wish that the exam papers are not going to be this hard. But I think the exam for the take-home exam, oh yeah, so congratulations, we're having, can you hear me, Cap? Congratulations, we're having the exam as the take-home exam, so we can somehow discuss with each other and share our answers. Shh, don't tell anyone about this. Okay. So then we can continue next to our so it's ready to the second session already. So this is not an exercise, not a tutorial exercise, but let's solve with me. Let's solve together, because I'm also stuck with this exercise as well. I think this kind of exercise might come up in the take-home exam because we need to use Excel. But I'm hoping that it's not going to be this hard. Or it's easy for you guys. I'm not sure. Right now, I am thinking that it couldn't be the same because did they give us a specification of each? No, they only tell that it has the same length and diameter and code. So it has L, D, and F is the same, but doesn't say how much or how many. So we can just cancel K out, right? We can factor it out because K is the same. Oh, I'm so smart. Hey. But the thing is that I want to know if we can cancel this out. I want to know if we can cancel this out. Like A 2 plus B. Can we cancel this out? No, right? Good thing. No one is answering me. I'm sad. 100 minus HJ. So just in case we cancel this out because they're the same, equals with square root of HJ minus 550 plus. There are many possibilities, right? Or no? We need another equation. Right, we need another equation. But all we know is that Q is not equal, right? What should we do now? Okay, to this point, let me try using the calculator. If it works, thank me later. It's alpha x, no, it's 100 minus alpha x equal to square root of alpha x minus 550 plus square root of alpha x minus 10 self. Don't tell me that it's going to work. Yes, it is. It says can solve. I just want to share this into I want to show this right now. It says can solve. You will see, you'll hear me trying to say a lot of things here. So now we're not going to find anything. Okay, I will come back to this later. We have this one left, right? Calculate this charge in the direction of flow. Oh, there's only one left. Is it? And we have this one and this one. This one's up there. We have 3 more left. Let's work this out until it gets the answer together. So in this case, okay, I'll just show what's going to be in the table in the Excel. I don't care anymore. So we will have the HJ, we will have the QAJ times with square root of K the q of, not the q of JB times with square root of k, and the q of JC times with square root of k, and I need to be larger, right? Craving for some fizzy drinks. What am I doing here? Q 2 plus 3. Yeah, so I don't know why it is so silent. Um, um, I'm trying to think there's another way that we can do it without doing this, but I'm sorry guys, I still cannot. I still cannot find a way that we can do this one. Why is it so loud outside? Let me try. I will turn off my microphone. Okay, so I forgot to turn on the microphone for the whole time. Bravo. Do I have to delete everything and write it down again, or? So basically, it's like this. Um, I had to create this table because I have no other way to solve this one without trying to do this table. I didn't use Excel, just used the calculator earlier. So the thing that I was trying to do is to pick up a number that I can substitute inside this one, and I can get the answer. The final here equals to this one, but yeah, I tried 70, but then um wait, why can't I use 70 that time? Maybe because I thought like the closest to this number is easier to have the match better, right? So I start with 50, so I want to look like what's going to be after 50, but of course I know that it can't be 50 because if it's 50 it's going to be 0, and this one cannot be equal to this one. So it must be a little bit higher than 50, but not over 60, because 60 would look like a little bit very high enough, because this would be square root of 40, and if it's 60, square root of 20 plus square root of 60 would be 50. Yeah, it would look like a very huge number, so it's going to be 50.5, but then I see that it's going to be a little bit slighter higher than this one, like 0.3, and this is 0.76, so that's quite a lot. It's not on the third digit, that's why it's on the second digit. So I tried 50.45, and this is the answer. I tried 50.45, and this is the answer. I want to go for another try, 50.46, but I'm not sure of what the answer is going to be. So in this case, 50.46, 7.0384, so we can cancel that out, and 50.46 minus, yeah, I was doing all this kind of calculation and I forgot to turn on my microphone. 0.6782, so we can cancel that out again. 10. Answer is 6.361 plus with 6. Ooh. I would love this answer better, because this answer is giving us this part here. You can see that this is going to be 46. Oh wait, no, 7.038, and this is 7.039. So you can see that this it's the third digit, but the third digit is only 0.001 difference, whereas in this one it's like, do I need to calculate to calculate it? 0.39 minus 7.308. Yeah, 0.0082. This is 0.001. So this is less than 0.0082. Okay, so finally I got the answer for this one. So what's the answer? Oh, no, it's HG. What were they asking again? Head at joint J. For as for now, um, we can stop here, and I will come back with later with all these three exercise, three problems, and with the problems that we're going to prepare for our exam. Okay, so good luck, guys. I'm going to be very busy until next week, so I know you haven't watched this video yet, but please send me some virtual support if you watch this video. Yes. nice. Okay. Thank you guys. Thank you for watching.